Introducing you the connection methods supported by the ELS Series residential hybrid inverters, along with key considerations for each setup. Photovoltaic systems typically fall into four application scenarios: pure off-grid systems, poor grid quality, unstable grids, energy storage systems. A pure off-grid system operates completely independent of the public grid. In this setup, the battery serves as an energy buffer. It stores power generated by solar panels or generators and supplies electricity when the generator is off, at night or during periods of low solar production. Although less common, some regions experience severe voltage drops, overvoltage, or other grid issues. In these cases, users often rely on inverters to power their loads instead of connecting directly to the grid. However, if the grid is stable, direct grid power is generally more efficient than inverter operation. In many countries, the grid is available but prone to frequent outages. When the grid is present, it can charge the battery. When the grid fails, the system switches to inverter mode to keep essential loads running. This scenario is similar to applications found in homes, vehicles, and marine environments. Energy storage is the newest and most important application and the main focus of today's video. Batteries store excess electricity for later use, enabling self-consumption and improving energy independence. Let's take a closer look at how this works. A basic system includes the grid and the household loads. We can add an AC-coupled PV system consisting of a grid-tied inverter and solar panels. If the load is higher than solar generation, all solar power goes to the load. If solar generation exceeds the load, the surplus is exported to the grid. Adding energy storage. A meter is installed between the grid and the PV inverter. The meter sends data to the hybrid inverter through a controller. The energy storage system keeps the meter reading near zero. When excess solar power is detected, the battery charges. When there is a power shortage, especially at night, the battery discharges to support the load. Because the hybrid inverter is always active, it can continue supplying backup power when the grid is available. However, if the grid fails in this configuration, the normal load section will shut down. Connect the PV inverter to the generator port. This ensures the PV inverter continues operating during a grid outage. Solar power can still supply the load, and excess energy can flow through the hybrid inverter. Add DC-coupled solar panels. Since the ELS includes a built-in MPPT solar controller, DC-coupled solar is the most efficient way to charge the battery. Solar power can supply both critical and normal loads, charge the battery, export to the grid if desired. The ELS hybrid inverter is compatible with a wide range of solar panels. Flexible combinations. All of these connection methods and combinations of them are supported. In regions with frequent or long-lasting outages, we often recommend combining AC-coupled PV, DC-coupled PV, and energy storage for maximum resilience. Additional notes. The ELS can assist loads as small as 100 watts. If the battery is sufficiently charged and the load is stable, the inverter will continuously output power to maintain a zero reading on the meter. The system can operate without a meter by connecting all loads to the inverter output. As long as the total load does not exceed the inverter's rated power, the system runs stably without manual intervention. If your dual system setup fails, it can be converted into an energy storage system without rewiring. The system can also operate without solar, storing electricity from the grid. This allows utilities to store excess wind or solar energy during peak production and release it later when needed. The ELS residential hybrid inverter is a next-generation product compatible with DC-coupled MPPT solar panels, AC-coupled grid-tied PV inverters, multiple battery brands. It supports all the connection methods discussed today and features a built-in color touchscreen. Most system configurations, such as power limiting, charge-discharge settings, energy storage modes, and zero power calibration, can be adjusted directly on the screen without a laptop. More detailed installation and commissioning videos for the ELS series will be released soon. Thank you for watching.